Hi everyone. Today I want to tell you about basically serverless deep learning and how you can start to use it. So first of all, let's look at what is usual data science process look like if you want to develop a deep learning application. You start with business understanding. You try to get problem. Then you try to acquire data to solve this kind of problem and process it. Then you build and train your model. Next step, you deploy it. And finally, you need to receive customer feedback to understand like what did you write and what did you do wrong. The problem is that actually final 3 steps are not like step-by-step process. It's more like iterative process where you have to first build some type of model and get customer feedback as early as possible. And you have to stay flexible, so you cannot invest like a lot of resources into building monolithic architecture, because if you receive negative customer feedback, you will understand that you need to rebuild everything from scratch. And finally, you need to understand how you can integrate your model inside your existing infrastructure. And sometimes it can be an issue. Today I want to tell you how a serverless framework can basically help to tackle these challenges. So what I want you to take from this talk is that to understand how serverless deep learning works, what are possible architectures and use cases, do's and don'ts, and end with some live coding session, so to show you how simple deep learning, serverless deep learning is. So let's start first of all what I mean by serverless. By serverless, I mean function as a service. Basically, when we say something as a service, we have a very big spectrum. You can have on-premise server, meaning it's server like physically in your location, where you have everything in control. Basically, blue means that you control it, and green. And up to another part of spectrum is software as a service, where you basically don't control anything. Function as a service comes very close to SaaS, but it's still not SaaS, because you can control code which is executed on the platform. And you don't have to control anything else behind it, so it's good. AWS Lambda function is AWS implementation of FaaS. So how does Lambda work? So you configure code, libraries, and configuration, which is basically memory which you're going to use, maximum time for the Lambda, and so on, and configure triggers which your service will receive. Once AWS Lambda service receives trigger, it puts configuration within a container from the pool, runs trigger, and produces response. After that, it keeps a container with configuration for some time, so up to 5 minutes. And if you get new trigger during these 5 minutes, it will be processed a lot faster. So this is basically the difference between what people mean by warm container and cold container, and warm start and cold start in function as a service framework. So what can actually act as Lambda triggers within AWS? You can have DynamDB, meaning that your Lambda will react to each new entry in your database. It can be S3 bucket, where Lambda will react to each new file in your bucket. It can be CloudWatch, which is basically a cron job, which you can configure to run, for example, every day, or every 1 hour, or every 5 minutes. It can be Lex, which is AWS platform for chatbots, meaning that you can make a chatbot backend using AWS Lambda. It can be a query service, SQS, if you just want to make some kind of batch processing. Or the simplest, like it can be API gateway, so you can build REST API. So what are some of Lambda's pros and cons? So it's extremely easy to deploy. So you don't need to know Docker. You don't need to know anything about containers. It's extremely easy to connect to other AWS services. So it's easy to create like the whole process within AWS infrastructure. They're very scalable, and they're relatively cheap. Cons is that logging is very specific, and it exists, and it's good enough, but if you used to have different systems for logging, you will need to implement it by yourself. It can be very hard to reproduce the whole Lambda environment on virtual machine, meaning that if you have some bug, it can be hard to reproduce. And the whole thing which I told you about worm containers, right now AWS doesn't have system to monitor how many worm containers do you have, what is statistics about worm containers, and so on. Or if, for example, if you want to keep containers warm, you will have to do it by yourself, basically running Lambda every 5 minutes, for example. And there are certain limitations. So there are no more than 3 GB RAM for Lambda, not more than 500 MB hard disk, not more than 5-minute execution time, and you have CPU proportional to provisioned memory, meaning like if you configure 3 GB RAM or 1 GB RAM, it won't be the same CPU. So CPU will be a lot lower in second case. So next, basically, why I decided to put TensorFlow on Lambda. Because, well, I think it's 1 year ago, it maybe was not that evident, but now TensorFlow basically rules the world of deep learning. And since a lot of latest updates, TensorFlow now has Keras in the core. So if you have your model trained or built in Keras, you can start actually using it on TensorFlow. And actually, TensorFlow introduced a lot of machine learning algorithms and frameworks. So they have their own version of boosted trees, which is not better than XGBoost or LightGBM, but there is boosted trees. And other ML algorithms like Kamins and so on. So follow releases, and there are more and more things coming. So why actually would we put TensorFlow on Lambda? So like for model, we can get a relatively good pricing. So 20,000 runs for $1, it's a very good price for a start. It might not be that good if you have 1 million requests per month, because it can get a little pricey. So you may need to switch to container. But if you have your pet project, you won't get more than $1 per month. There are like 1,000 concurrent executions, but you can write to AWS support. So this number is not like physically limited. You can ask AWS support to increase it to 10,000, 100,000, so any number basically. And it has pay-as-you-go model, so you don't pay if your model doesn't work. So what are the main implementation problems with putting TensorFlow on Lambda? So basically, Lambda limit for a package is 50 megabytes. TensorFlow by itself just 43 megabytes. And you have to have NumPy, which is already 16 megabytes. You see there is some inconsistency. Funny thing that actually you don't have to follow this 50 megabyte rule. It only works if you upload archive straight to the AWS service. But if you use S3 bucket to upload the code, the only limit you have is 250 megabytes unarchived code. It makes a lot of things easier. So what is the solution to decrease the size of archive? Basically, I have a shell script in my GitHub repo, which shows which you can just run in the Docker container, which will gather the whole pack for you. So you just need to have Docker with Amazon Linux and install all libraries, and then produce some magic, which is basically compress shared libraries, delete PIC files, and delete everything which is not needed for TensorFlow. So how we usually import models, like when we have TensorFlow and then AWS Lambda? So if we use TensorFlow, then we use PB files, protobuffer. If we use Keras, we can actually get H5 files. But the main part of architecture that we store models on S3. Although I should say that if your model is not very big, so we're not speaking about like VGG16, which is 1 gigabyte, but like for something which you just did for your local predictions, and it weighs like less than 10 megabytes, then you can actually store it with the code. It will significantly improve your speed. So next, I just want to show you comparison how like traditional AWS infrastructure for deep learning looks like, and how it will look like with serverless. So here's how it looks like in traditional native AWS services. And it's pretty normal architecture. It's not something exceptional. So the application which we are trying to build here is API for image recognition. So we have Route 53, which will handle requests. Then we have not route 53. So automatic load balancing, it will handle requests. Then we have cluster, where we have automatic scaling, which will scale your cluster size and will have to work to understand what your will help you to configure the price you want to work with spot instances, and it will get a model from container registry. With Lambda, the same application would look like something like that. So you just have Route 53 connected to API gateway, connected to Lambda, connected to S3, that's all. And it's easy to start. You don't have to know how Docker works. You can do it literally in one command. So another application, which usually more popular within companies, is when you need to make some batch processing. Then you just connect SQS to Lambda, and here you have completely serverless batch processing. Meaning, if you have, for example, in your company, you have to process 10,000 images. 10,000 images, like links to these images, will go through SQS, and then they will make 10,000 lambdas, which will process it. And the whole thing can be processed in less than a minute, because they will be concurrent. But if we're speaking about like closer architecture which closer to production, it makes sense to actually use step functions. Step functions helps to organize lambdas and create workflows. So let me give you an example of some application where we can use step functions. For example, we can use the function, we get one lambda to get image. Second lambda will run tcract, which is OCR service on top of this image to get text. Then it will check if recognized text is good, recognized text is good or bad. Then it can run Spacy, which is a library for natural language processing, to understand what was actually written, and then to get vector, basically. And then you can run your TensorFlow model on top of this vector to categorize what you received. And with this kind of workflow, we kind of build a deep learning application which can segment text on the photo. And the main thing here is that this kind of model approach enables to handle errors and special cases. So if error happens somewhere, you can handle this case. It allows you to A/B test your model. So if you have different versions of the models, you can direct your traffic, which goes here in different ways. For example, if you have new model and you want to try just to test it on a smaller amount of user, you can just make 1% of traffic will go through new model, all other percent will go to old model. And here we're going like from the concept of serverless functions to the concept of serverless workflows, because here we still completely serverless and completely scalable and completely pay-as-you-go model. So we don't pay for what we are not using. So where to actually get models? You can train yourself if you have data and you have like business problem. But actually, deep learning industry produced a lot of open source models which are free to use and you can easily integrate. So you can just download pre-trained model and treat it as a library to solve your business solutions. If you want to segment image, recognize objects on the image, or do any stuff, you don't actually need to know how to train models. You can just put them inside and run it for your business needs. Next, I want to present you two projects which were done using this concept serverless deep learning. So one which is like on my GitHub repo, which does image recognition. Basically uses Inception V3 model and has the cost of like 20 to 30,000 runs per $1, which is like a standard made from standard TensorFlow tutorial. Next project is Accessible Web. Basically, it's a Chrome plugin which uses API to make image captioning and describe what happens on the image for people with disabilities. And it actually reads it to them. So in that way, the developer used image-to-text model, which also was already pre-trained. So he didn't have to train model by himself. So finally, after these two projects, how do you know if like the whole serverless deep learning is for you? If you want to deploy your model just for your pet project, it's perfect. Zero investment. You can just start it like in 5 minutes and share REST API share the link with anybody. If you want to make MVP for a startup and project, it can be very good because you have extremely flexible infrastructure and you can easily change it. It's a fast way to change check your assumptions and check business assumptions. Third, if you're DevOps and you have a very simple model, then this kind of infrastructure, this serverless deep learning, will help you to reduce cost, because for this kind of stuff, cluster will be more costly. And finally, if you have peak loads, not standard loads, and it is hard to manage cluster, because like if you have like 10,000 requests this minute and you have 0 requests next minute, then it would be extremely hard to manage that kind of load with cluster. So either you have always a very big cluster and you cannot reduce its size, then it's very costly, or you have to think about something predictive, which is hard. But also, it was mentioning second slide, how do you know if this is not for you? First of all, if you have extremely complex model that either needs a lot of data or needs a lot of CPU, then you're probably limited to that. And second, if you need to have extremely fast response, because like lambdas, and by meaning fast response, I don't mean like when you want to process like 10,000 requests in a batch, then lambda will be good, because like you don't have you need to think about like how much time you need to process 10,000, not a single request. But if you want to have like API which works extremely as fast, then lambda won't be for you, because as I will show later, it will take like 2-3 seconds basically to run. Average like TensorFlow inception v3 model, but still. And just additional stuff which I did recently for as additional packages for AWS Lambda. It's LightGBM package, which is pretty good boosted trees, which you can use, and Spacey package, which is natural language processing library. So in conclusion, I want to say that serverless deep learning is extremely convenient way to do a lot of stuff. So it's a great thing. And now let's go to some live coding. Yeah, I just need some time to switch displays. Okay, so basically, here's my repo with different libraries which are ported for AWS Lambda. And it's MIT license, so feel free to download, edit it, and use it for your projects. So if you just enter the TensorFlow, you will see that you have this pack.zip, and you can just download this pack and actually just create a Lambda function. I think we have time, so I just want to show you how we can create it from scratch. So you just need to put Python to 7, choose some existing role. Give me a second. So now we have this function, so we can basically test it right from the scratch. It will now return just hello world, hello from Lambda. So the only thing which we need to do right now is to copy. So I have like this zip which I showed earlier in my S3 bucket, so I can use it. And here the only thing I need to do is to just choose file from Amazon S3, put file here, change the file which I'm going to, function which I'm going to start, put enough memory. Memory here is not like is not needed from the point of memory which we used by model. Model only needs 500 megabytes, but as I mentioned before, you have to have higher CPU if you want to have faster response. Yeah, so it ran on the Panda image, received that we have Panda. So here the main thing is you see that it's run for almost 5 seconds. It was a cold start. Now if we run the same thing on a warm container, we will get 3.6 seconds. And it's not like very optimized code, but like you can get even smaller than that. So how does it look like inside? Basically, one of the main tricks which you need to know is that warm container actually keeps all files on its hard disk and all global variables in its memory. So basically, if we create global variable session, and we will keep TensorFlow graph basically here, and we keep the whole session actually, like, so not only graph but the whole session in it, then we will be able to, on the during the warm start, we won't need to load anything from S3. We won't need to load anything like in the memory. We will have access to existing graph. Okay, so there is that, and like here you can see that you can do basically the same thing, and you will have deep learning. Once you integrate it within your company, you can start claiming that you have AI. Hopefully, it will increase your company stock. Okay, thank you very much. That's all. So if you have any questions, I will be glad to answer them. Also, I have this presentation, a link to this presentation on the O'Reilly page, so you can download it from there.
So, I guess for typically when we run it in like local machine learning models internally, we have to expose it as an API and do all that stuff. So all this will take care of that, right? So all you need to do is just dump your model, but you need to still invoke it, right?
Oh, what do you mean, like?
Like, so when we build a model, we build the model and then we export it as a file somewhere, and then that file is exposed as an API to be invoked during runtime.
Yes, so there are two ways basically. So you have to export model. So depending on framework you're using, it can be different file. So there are two ways. If you have, if model is small enough, then you can basically keep it with the code. Because like 250 megabytes, in these 250 megabytes, TensorFlow with Keras is something like 150, 180. So you have like up to 50 megabytes of for your model. So if it's less than 50 megabytes, it makes sense to keep with the code. If more than that, you have to download it from S3.
Okay.
But one additional thing which I want to mention, that actually you can download a model from S3 straight into memory. So you don't have to do it via hard disk. So you don't have 500 megabytes limit for your model. You can actually can use up to 3 gigabyte model size.
Another question? Got some time? Okay.
Okay.
Thank you very much.
Thank you.